Hi, everyone. I'm very excited to give you this topic. Maybe this because it's holiday is coming tomorrow. And also this topic is very popular. And when I do research, I found many information, but it's very difficult to consuming. So for today, we'll use 30 minutes to talk about this high level take considerations when you want to deploy generative AI on-prem. Before we start these details, we can briefly talk about the benefit for this on-prem generative AI. I think there's two main benefit. The first one is obviously you keep every data on-prem within your network and organization. What does that mean is every time, for example, we talk with ChatGPT or another open generative AI application, your questions, and also if you have some data, context data relevant to your questions, will send over to this generative AI model, which could be hosted overseas. So we don't want to do that. And we want to keep everything, every data we have within the organization. So that is the first benefit. The second benefit is really to leverage the richness of the open source. So as we know, there's some generative AI. If you are checking on different vendors, there may be 10 different models or over 100 different models on the platform. But in the open source, there is over 600,000 generative AI models there. And there is models specialized for a specific use case, specific for some language, and for some niche area. So it's really to find the right model for you, which is a good benefit, instead of just go to this massive model, which is expensive and very slow. So that is the second benefit. Then with these two benefits, but in reality, it's not easy to deploy this generative AI on-prem. So, and I think there's two main considerations when you do this. One is which model I choose as like engine of my application or engine of my generative AI model. The second key consideration is what is the hardware requirement I need to host this model for my customer, for users to interface. The third one will be the governance part. I will talk that briefly later as well. And this is open source large language model selection framework. There's mainly 4 steps you can go through to pick the right model for your project. And we start with identify use case. Then based on the use case, we will list all the options we have, which model we can use. Then will be the evaluation testing to test these options, different model, which one can meet our requirement. Then the last step is choose this model who gave us the best business value. And under all these 4 steps, there is a governance to make sure the model is safe and the data is security. So then we'll go through one by one. The first step is to identify the use cases. So we start with high-level use cases. Based on this IDC, there is 5 common use cases, like knowledge management. For example, when you do a intelligent search, the search result will give you the answer directly. You don't need to go through all these details like the Google, check different website. It will just give you the answer directly. The second common one will be the conversational application. That is like a virtual assistant for customer care or for internal HR chatbot. They also have the code generation to help developer improve their daily productivity. And with this high-level use case, it's not really help you to pick which large language model. So what we can do is we try to break down the high use cases into tasks. Will be like a collection of tasks. For example, for the conversational application, let's say we want to build a customer care virtual assistant. So if we break down that, there will be model to answer customer question. There may be model to generate or convert text to audio and also to convert audio to text. There could be model for you to search your database to get the information. So that is what I mean when you break down the use case into task. Then within the more granular level for task, that will be where we pick the right large language model for different task. That will take us to the second step, the options. So where we go to find all these options we have. So that I'll introduce you. This website is called Hugging Face. This website is really this open source AI model hub. In this website, you can see we have over 600,000 models, and some filter I think is very helpful for us to use will be first this on the left. You can see there's a tasks, and based on your task, you can choose the model, filter the model you want. For example, we can do this text generation. This is the most common one, like ChatGPT. But there can be also other tasks like image. For example, we want to have image to text. You want to generate some image. And also there is a sort function. Based on my experience, maybe you just go with the most downloads. So that one will be like have the most people try it out, and also most likely it from this large corporate, they have this resource and expertise to develop this. Another one I want to call out will be this license. For example, if we go pick one specific model. First of all, the license part is to make sure that model is okay for commercial use case. Most of this model is allowed for this commercial use. There can be specific like condition for you to notice. For example, for this Meta Llama 3 or Llama 2, it asks for if you have more than 700 million monthly active user, you will need request a special like a different license, but that is very large. It's more than the population we have in Australia. So basically is open for commercial use, but there's some fine print and you want to check, make sure it is works under this license. So here we can see what options we have, and then we'll pick a couple that for our solution. Another key information we need is to roughly estimate how many GPU we need to run this model. There is many calculations for you to do that. I think this one is very simplified to remember is the GPU is basically twice of the number of the parameters. What I mean, for example, we talk about the Llama 2 7 billion model, which means it has 7 billion parameters. And for each parameter, we assuming that is a 2 bytes, the size of each parameter. So that's why we multiply 2, which gives us 14 gigabyte GPU memory. So that is like, in theory, you need that many GPU, and we give a 20% more overhead. That will give us around 17 GB to run GPU to run this model. And for that part, if we think about this GPU offering on the marketing now, for example, we take NVIDIA, there's a T4 that is like small size GPU. It has 16 GB memory and the A10 and A100. So we can see here, T4, we can basically run a 7 billion model. And A10 24 gigabyte. That one we can easily to run a 7 billion model, maybe even larger, like 10 billion or 8 billion model we have from Llama 3. So that is very high level, how much GPU you would need. With that, we can come to these key questions when you choose this model. This question is like, do my use cases need a massive model to run this task? And most use cases, the answer is no. And I think there's a big motivation behind this is if you want to do a large model, for example, this 70 billion Llama 2, then you will need a A100 GPU. That is over 10,000 US dollars. I think that is a very large motivation to ask this question. Do I need a large model to run this? Most use cases we have seen, the smaller model, 10 billion, 8 billion, or 13 billion is good enough to give you the performance. And with that, we will go more detail on this GPU part and the performance part. So after we have the options we have, for example, we want 7 billion, 13 billion, maybe we try 20 billion model. We have 3 models. Then when you do evaluation, there is a 2 part to do that. One is the speed for the model interface. So here we mainly talk about this model interface. We don't talk about this train the model from the scratch. The second part will be the accuracy for the model. Maybe we start with accuracy. So based on your use case, there can be 2 metrics you can use to do the accuracy testing. One is like if you want the generative model to classify your email or to do sentiment analysis, that one will be more traditional machine learning. So you basically testing this accuracy metrics. If you want to use the model to summarize your email to generate a new marketing material, so that is more like generative task. There will be other metrics like Blue or Rock for you to do the testing. And all this is open source. There's many material to do that. The other part will be the speed of this interface. And when you talk about speed, there will likely is like low latency. And also there's like a trade-off for concurrency or throughput. What I mean for the trade-off, basically, if you want to have high throughput, that means your model will handle multiple requests at the same time. That will cause this high latency. But if you have only one request, the model will use all this resource to finish that request. Then you have the low latency. So there's a trade-off for different use case. Here is some high-level reference for you to understand this. For example, if we use A10 model, run this Llama 7 billion, it can roughly support this concurrency, maximum concurrency as of 4 users. Basically, like 4 users can access your model or interface your model at the same time. If there's more than 4, there will be like a more high latency or waiting time. The 5th user will be in the queue to waiting for the response. And if we go 100, that is a 20 user concurrency. Then on the right side, there is a table to show you more straightforward for this interface time. The testing is based on a simple task is to summarize around 250 words into 100 words. So that is a task. So overall input plus the output is like 350 words. Then we run that on different GPU. You can see T4, that is around 7 seconds. A10 is 3.5, and A100 is less than 1 second. I tried this in ChatGPT, the website we all have access, is around 2 seconds. And we all know there's some wait time for ChatGPT, so it can be longer than two, but it will give you idea what is like a common or people will more acceptable is like 2 seconds, and A10 can do that with this we'll say relatively low latency, but that is can only support 4 users. If you have more than users access it model at the same time, that will be longer. Besides the interface time, you can see here will be the list price. That will be based on the cost of GPU. What is the difference? So A100 is like 10 times more costly than T4. Here will be this evaluate performance side, and may cost is come from this GPU cost, and then you will basically do the trade-off of your latency and the throughput based on your use case. So another part will very important is regarding the governance. This can be part of this evaluation, and will evaluate the model reliability. So what key factors we can think about is make sure the model gave this consistency and trustworthy with this model, and also it can avoid to answer some question with inappropriate content or bias. That will raise another task like red team testing. So that is a very big part of this when you release your generative AI to a production ready state. Typically, there's like reference if this model give you more transparency on how this model is trained, what data is used, that is more reliable when we consider this reliability. So where we can find that information is basically from this model release. There will be some technical report behind that model. If this technical report give you more detail on this training and data, that we can put more trust and more reliability. But it's not always the case since it's open source. You may know this before. So this, I think, is April 16. There is a Wizard large language model, part of the Microsoft. They release this model, and you can see in this red box, it outperformed GPT-4 and very close to this Cloud model. So that is a big news since all this top 4 and top 5 is closed source, and this Wizard large language model is open source. Then a few moments later, they have another Twitter post. They have to withdraw this model since they missing very important testing is toxicity testing. So that is part of the red team testing. So they withdraw that and they do more testing. So this is happened in very recently, and also mean the open source model, we do need to be aware of this risk. So that is for this AI large language model selection framework. And within tech data, we also have some initiative to try to deploy AI model on-prem and also put a front end in that as a use case. So I will quickly show you what we did and talk about this, what works, what doesn't work. So just open that now. This is we call that Chat GPT-like application hosted in our tech data COE lab, and I connect this with via VPN, so that you will have your login account, and this one the use case here will be very easily like this RAG use case. Basically, you can use generative AI, talk with your enterprise data. This is a main page. For example, I can easily upload some document into this from this front end. You can see on the left is my document, and this is document already in the database we want to query. There is one document, is a PDF for IBM annual report. Then here I just ask a list of questions. What is basically summarize the report IBM 2022 performance, and what is the revenue for 2021, and all this response is generated based on model is Llama 2 13 billion, and for that one you can also configure that as well. So you can see this general setting, chat setting. So you can see the chat model here. We have different models, and the vector database basically where you host that data. For this one is great. I think we have this as a kind of a start point for internal use. That is great. And also another point is for this one, we host it on CPU. So like it's a CPU only, you can see the detail for the hardware. But when we do this testing, like we have 2 or 3 people to use this tool at the same time, it only works for 1 people. So the other 2 people just waiting in the list forever. It doesn't give you any response. So that is the limitation for CPU. Another part is we don't have many governance or best practice to manage access in this tool, which will be a big part. And also is not always working. So it will take some time from our software developer team to we'll say actively maintain this. There are always some small issues. It come up and it doesn't work. So that is lead us to this page. So I always think it's a great analogy when you think about you want to use open source to get some production ready application. It's like you have a you kind of make a car from all these different components. You can imagine the expertise and the experience you need from your team to build this production ready application from the open source. Then will lead us another question is, do we have any offering on the marketing so we can do this like the generative AI as a platform, but offer as a software. So you can just install the software on your Prime, on your hardware. And for now, we do have one is from IBM watsonx.ai. So IBM watsonx.ai, this offering is pretty good. It's a bundle of IBM service, which can be used to deliver most of these common use cases we mentioned earlier. So this bundle, including generative AI, including the data store like lake data, lakehouse data, also including the voice assistant for your conversational AI, speech to text, text to speech, and also the best. Another great attraction for this offering is the price for the license. So if we can see here is the 2 options. On the right side, this option is for 2-year term, and is only based on the size of your use case. For example, for small size use case, that is for 50K US dollars for 2 years, and every month you will have maximum 5,000 users to access your application. For example, the virtual assistant or internal HR chatbot. And if you have a larger size, you can see here 100K or 200K. With this offering, there will be many use cases you can build based on this. Some common one will be, for example, the digital assistant for customer support, or you have your internal employee experience to automate some task to help your employee get work done. use generative AI to summarize or to extract data from the file. So that is for this offering, and there is a reference for you to host this offering on-prem. You can see this estimation is more than we had before. That is because the offering put together this governance, put together other front end for the Watson Assistant, also have this search vector database. So this one is more realistic and production ready for your hardware and storage to host that generative AI platform and generative AI applications. We can talk more details offline if you're interested or your customer is looking for some generative AI on Prime. That will be for today. I will pause here. If you have any questions or comment, or you want to hear more for our next webinar, feel free to ask. Thank you.